Everyone knows explosions are cool as...
But what you might not know is these explosions can be easily explained by a handful of scientific laws.
Most explosions happen when there's some type of gas in a container.
When the pressure of the gas inside grows bigger than the strength of the container breaks and boom, explodes.
For example, dynamite. Highly explosive, it ignites with gunpowder.
Which can be made with a compound called saltpeter, KNO3, and charcoal.
Saltpeter can be found in cold packs, tree stump remover, or urine.
All explosions, from dynamite to natural chemicals, like mixing ammonium nitrate and fuel oils, can be explained by Gay-Lussac's law, a relationship between temperature and pressure.
Gay-Lussac's law can be defined by the formula P1 over T1 equals P2 over T2. In other words, if you increase a gas's temperature, its pressure will increase as well.
The gases stored in dynamite first increase in temperature, which then causes the increase in pressure, then causing it to explode. To demonstrate this explosion, Owen and I bought a big thing of Coke and a thing of Mentos.
Although dynamite and other explosives have a high impact on their surroundings and are typically quite dangerous, Coke and Mentos still reflects the key concept of the idea itself.
In an article from Scientific America, they explain exactly why Coke explodes when in contact with the hard, flat candies. When we say flat candies, we mean only at eye level. In reality, if you were to look at these candies under a microscope, you would see they were actually really rough and bumpy. The bumps from these candies allow the carbon dioxide to separate from the water in the soda at an alarming rate, causing the soda to explode from its canister. Is that a real word?
Whereas Coke and Mentos only releases CO2, actual explosions can release all sorts of dangerous gases and debris. Now, allow us to demonstrate. Now, imagine if, instead of an open spout at the top where the soda could shoot out from, this container was sealed shut. The same reaction would occur inside, leading to the molecules moving around faster and faster, but there would be no place for them to go.
Instead, the molecules keep moving inside the container, gradually increasing the pressure until eventually...
Charles's law is very similar to Gay-Lussac's law. Instead of relating temperature and pressure, Charles's law relates temperature and volume.
Charles's law states that V1 over T1 equals V2 over T2. That means volume is directly proportional to temperature.
But how can you use this idea to cause an explosion? By heating up gas, you can cause it to expand.
Imagine you fill up a balloon with cold gas, and then you heat up that gas. The balloon will expand, even though you didn't add any more gas.
The balloon expanded because the temperature increased. So the volume had to increase directly proportionally due to Charles's law.
Similar to Gay-Lussac's law, the increase in volume can be dangerous. We've all seen a balloon pop because of the increase in volume. Now just imagine an explosion cranked up to 10 million. Speaking of, I have 10 million power.
In actual dynamite, the heat of the ignition, whether from gunpowder or any other source of heat, can make the particles in the gases move at rapid speeds, increasing the pressure in the dynamite and leading to its eventual explosion.
The Mentos directly represents the fuel used to cause these explosions, making the gases become more spread out until its eventual...
The danger of explosions usually lies in the fact that they initially take place in a confined space. This means that the volume is constant.
According to the ideal gas law, PV equals nRT, where V is constant and R, the gas constant, is constant, then the equation is simplified.
That means the pressure, P, would have a directly proportional relationship with either the temperature, T, or the number of moles, N.
Explosions can be explained by a handful of scientific laws.
Gay-Lussac's law explains the cause of an explosion with pressure and temperature. And the ideal gas law explains the explosive power when everything comes together.
So just remember, explosions are cool as...
Two, one, action.
Everyone knows explosions are cool as heck.